What if 3I, Atlas, is an alien spacecraft? On the 1st of July 2025, a robotic telescope in the Atacama Desert of Chile, part of a survey called Atlas, picked up a streak of light moving against the fixed background of stars. Within 48 hours, the orbit was confirmed. The object was not bound to the Sunday. It was on an open hyperbolic trajectory, moving fast enough to escape the sun's gravity entirely. That single fact meant only one thing. The object had come from another star. The survey's lead observer, Tessim Zwicky of Caltech, designated it A11PL3Z on the 2nd of July 2025. Within weeks, the International Astronomical Union gave it the formal name, 3I, Atlas. The I stands for interstellar. The 3 means it is the third such object ever confirmed. The first was 1I, Oumuamua, detected the 19th of October 2017 by the Pan-STARRS survey in Hawaii. The second was 2I, Borisov, detected the 30th of August 2019 by an amateur astronomer in Crimea. The third is 3I, Atlas. The 2017 visitor was an oddly accelerating rock that Harvard astronomer Avi Loeb argued might be artificial. The 2019 visitor looked, on every measurement, like the first thing astronomers computed was the path, 3I. Atlas entered the solar system from the direction of the constellation Sagittarius, in a path that took it past the inner planets, then around the Sun, then back out. The closest approach to Earth was on the 19th of December 2025, at a distance of 1.8 astronomical units, roughly 170 million miles, far too distant to be a threat. The closest approach to the Sun, called perihelion, was on the 30th of October 2025, when the object came within the orbit of Mars. By the time 3I, Atlas, reached its closest point to the Sun, it had developed a fuzzy coma, the cloud of gas and dust that forms when a comet is heated. That alone made the object look, on first inspection, like an ordinary comet. But the path itself was not ordinary. The velocity at infinity, the speed the object would have if the Sun's gravity were removed entirely, was roughly 60 kilometers per second, more than 3 times the speed of any object bound to the Sunday. That speed meant the object would not stay. It would pass through and keep going, out into interstellar space, in a journey that would take roughly 130,000 years from one side of the solar system to the other. The path was also at a low inclination to the ecliptic, the plane in which the planets orbit. Most long-period comets in our solar system come in on paths that are tilted, often steeply. 3I, Atlas came in nearly flat, that is, statistically rare. The same flatness was seen in 2017 in the path of 1I, Oumuamua. Avi Loeb, in a series of papers and Medium articles written through 2025 and 2026, has argued that the flatness is itself a clue worth tracking. In late 2025 and through 2026, Avi Loeb, the Frank B. Baird Jr., professor of science at Harvard, the founder of the Galileo Project, and the author of the best-selling book Extraterrestrial, began publishing a numbered list of anomalies associated with 3I, Atlas. The list grew to 22 items. The first anomaly is the velocity at infinity. 60 kilometers per second is at the high end of the range for interstellar objects, but not impossibly so. The second anomaly is the trajectory. A flat, ecliptic-aligned path through the inner solar system is statistically unlikely. The third anomaly is the size. Estimates, based on the brightness and the activity, put the nucleus at roughly 20 kilometers in diameter, the largest interstellar object ever detected, by a wide margin. The fourth anomaly is the timing. The object arrived at a moment when multiple large observatories were operational, including NASA's James Webb Space Telescope, the ESA JUICE mission en route to Jupiter, the NSF Do Vera C. Rubin Observatory in Chile, and the SETI Institute's Allen Telescope Array in Northern California. The fifth anomaly is the lack of a clearly resolved nucleus. Most comets at the activity level of 3I Atlas would show a sharp central condensation. This one did not. The 6th through 10th anomalies include a faint radio signal near 1.6 gigahertz, 3 jets pointing in directions that are symmetric at exactly 120 degrees apart, a thermal emission pattern inconsistent with a single nucleus, an apparent anti-tail pointing toward the Sun, and an anomalous non-gravitational acceleration. The acceleration is the one most often cited. 1I Oumuamua in 2017 showed a similar non-gravitational acceleration that could not be explained by outgassing. The same is now being measured on 3I Atlas. In late 2025, NASA's James Webb Space Telescope turned its NIRSPEC instrument toward 3I Atlas. The instrument splits the object's light into a spectrum, and the spectrum shows the chemical fingerprints of whatever is outgassing from the nucleus. The results were released in stages through early 2026. The first published finding was the detection of methane. Methane had never been confirmed on an interstellar object before. The second finding, published in February 2026, was more striking. The ratio of deuterium to ordinary hydrogen in the water being released by 3I Atlas was roughly 1,000 times higher than the ratio in Earth's oceans, and roughly 1,000 times higher than the ratio in the Sunday. That ratio is a fingerprint of where the object formed. Objects that form in the cold outer regions of a protoplanetary disk, far from their parent star, tend to have high deuterium ratios. Objects that form in the warm inner regions have lower ratios. A ratio 1,000 times solar is consistent with formation in the very cold outer disk of another star, possibly in a region analogous to the Oort cloud. NASA, in a press release, called the water alien-like. The phrasing was deliberate. The water was, chemically, different from anything in our solar system. Karen Meach, of the University of Hawaii's Institute for Astronomy, the lead author on several of the early 3I Atlas characterization papers, called the finding a sample of another star's chemistry delivered to our solar system, intact, in a single object. The implication is straightforward. 3I Atlas is not a piece of our solar system that happened to be ejected. It is a piece of another solar system, formed under different conditions, and it has carried that difference in its chemistry all the way here. In January 2026, the NSF's NOIR lab, the National Optical Infrared Astronomy Research Laboratory, reported a faint radio emission from 3I Atlas at approximately 1.6 gigahertz. The detection was made by the NSF's Carl G. Jansky Very Large Array in New Mexico. The frequency is significant. 1.6 gigahertz is close to the hydrogen line, the radio frequency, at which neutral hydrogen gas emits and absorbs energy. It is one of the most studied frequencies in radio astronomy. It is also, by a coincidence, that Avi Loeb has highlighted the exact frequency of a signal detected in 2023 beneath the Skinwalker Ranch in Utah by a federally contracted science team and reported in the Pentagon's AARO records. The coincidence does not by itself prove anything. The hydrogen line and the Skinwalker Ranch signal are both 1.6 gigahertz because 1.6 gigahertz is a natural frequency in many physical systems. But the coincidence is the kind of detail that Loeb catalogues. The NSF NOIR lab team, led by Yuhui Zhu, did not assign any artificial origin to the signal. Their paper, published in early 2026, attributed the emission to the interaction of the comet's coma with the solar wind, a natural mechanism. The detection, in other words, has both a natural explanation and a non-natural one, and the data, on its own, does not yet distinguish between them. The detection also marked the first time a radio signal at the hydrogen line had been measured on a confirmed interstellar visitor. The same is not true of 1I, Oumuamua, or 2I, Borisov. 3I, Atlas is, again, the third visitor in the list, and the third in the list of firsts. In June 2026, the SETI Institute, the Search for Extraterrestrial Intelligence Institute, in Mountain View, California, completed a 144-hour targeted observation campaign on 3I, Atlas, using the Allen Telescope Array, a 42-element radio interferometer located at the Hat Creek Radio Observatory in Northern California. The campaign was coordinated by the SETI Institute's chief astronomer, Frank Marchis, and the Institute's Director of Interdisciplinary Science, Laura May Abron. The 144 hours were spent listening across a wide band of frequencies for any narrowband signal, any pulsed signal, any modulated carrier, or any other feature that could not be explained by natural astrophysical processes. No such signal was found. The campaign did not detect any artificial transmission from 3I, Atlas. The result was reported on the 21st of June 2026, and it is the first time a dedicated SETI campaign has been run on a confirmed interstellar object. A null result does not mean the object is natural. A null result rules out only what was searched, in the direction the telescope was pointed, at the frequencies that were tuned, during the hours that were observed. The Allen Telescope Array was not pointed continuously. This 3I, Atlas, was not in the field of view for the entire campaign, and the search did not include all possible frequencies, all possible modulation schemes, or all possible duty cycles. A null result is a constraint, not a conclusion. The SETI Institute, in its public statement on the 21st of June 2026, said the campaign was a first pass, and that future observations with more sensitive instruments, including the square-kilometer array now under construction in Australia and South Africa, would extend the search. Avi Loeb has proposed, in a series of Medium articles and a 2026 paper, what he calls the Loeb Scale. The scale is an attempt to formalize, in plain language, the probability that a given anomalous object is artificial, meaning created by an extraterrestrial technology rather than by natural astrophysical processes. The scale runs from 0, meaning the object is almost certainly natural, to 10, meaning the object is almost certainly artificial. On the scale, 1I, Oumuamua, the 2017 visitor, scored between 4 and 6. The estimate reflected the non-gravitational acceleration, the flat trajectory, the elongated shape, and the lack of a detectable coma. The score was high enough to keep the question open. It was not high enough to be a detection. 2I, Borisov, the 2019 visitor, scored close to 0. It looked, on every measurement, like an ordinary comet from another star. 3I, Atlas, on the Loeb scale, scores between 3 and 4. The score is lower than Oumuamua's because 3I, Atlas, has a visible coma and shows outgassing, two features that 1I lacked. The score is higher than Borisov's because of the 22 anomalies. The mid-range score is the heart of the argument. The object is not natural on every measurement. It is not artificial on every measurement. It is, on balance, more likely natural than artificial, but not by a wide enough margin to close the question. Loeb has called 3I, Atlas, a Trojan horse candidate, a term he uses to describe an object whose natural behavior is consistent with what we would expect from a probe designed to look natural on first inspection. The Trojan horse idea is, by Loeb's own framing, a hypothesis, not a conclusion. It is a way of organizing the data, not a way of resolving the question. 3I, Atlas, as of mid-2026, has accumulated 22 separate anomalies. The anomalies include the trajectory, the size, the timing, the lack of a resolved nucleus, the symmetric jets, the radio emission, the anti-tail, the non-gravitational acceleration, the high deuterium ratio, and the coincidence of the 1.6 gigahertz frequency with the hydrogen line. NASA, in its public statements, has consistently described the object as a comet. The European Space Agency has done the same. Alan Stern, the principal investigator of NASA's New Horizons mission to Pluto, has called the object, in a series of interviews, a perfectly normal interstellar comet with a lot of unusual measurements that have perfectly normal explanations we have not yet identified. Avi Loeb, in his Medium articles, has consistently described the object as the most interesting interstellar visitor we have ever catalogued, and the one most worth continued monitoring. Harvard Science Review, in a 10th of February 2026 article titled "The Alien Hunter's Last Stand," put the question plainly: to NASA, a dirty snowball; to Loeb, something else entirely. The object is now past perihelion. It is heading back out of the solar system. It will reach Jupiter's distance in March 2027. After that, it will continue out, year after year, decade after decade, until the time, roughly 20,000 years from now, when it reaches the heliopause and crosses into true interstellar space. The instruments that have been watching it will not be watching it then. The data, the spectra, the radio measurements, the velocity curves will be archived. The question of whether 3I, Atlas, is a natural interstellar object or something else will be carried into that archive unresolved. Either answer remains consistent with the data we have. The 22 anomalies are not a detection. They are a question. That question will be studied for decades. Whether the answer comes out natural or comes out something else, the question itself has already changed astronomy.